In this video, we're going to start our little unit on sequences. Let's start by defining what a sequence is. Simply an ordered list of numbers. So it could be 2, 4, 8, 16, dot, 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 meaning that the list continues. And the term is each number in a sequence. So here, our first term is 2, our second term is 4, our third term is 8, our fourth term is 16. Now, a sequence does not have to have a pattern to it, but in this case, I hope you can see all we're doing is doubling each time. If a sequence does have a pattern, there's two ways in which we can define it: the explicit rule and the recursive rule. So the explicit rule is a rule that defines the nth term, or a general term, of a sequence as a function of n. So it's a rule that says, here's how you find the 10th term using n equals 10. The recursive rule is a rule that uses the previous terms of a function, of a sequence, to find the current term. So to find f of 10, I need to know f of 9. So I'm using the ones that come before. So we're going to have a little bit of notation as we go through and look at these. Let's start by looking at just two examples where we're finding our terms. So the first example, we're going to find our term using an explicit rule. Our explicit rule says f of n equals 3n minus 2. So we're going to do this by drawing a table with n and f of n. And I want to know the first 6. So I'm going to do n is 1, n is 2, n is 3, n is 4, n is 5, n is 6. So to do f of 1, I'm going to do 3 times 1 minus 2. So I'm just going into the function. I'm taking out the n. I'm plugging in 1. So I get 3 minus 2, which is 1. To do f of 2, I'm going to do 3 times 2 minus 2, which is 6 minus 2, which is 4. To do f of 3, I'm going to do 3 times 3 minus 2, which is 9 minus 2, which is 7. See that we're adding 3 each time? 1 plus 3 is 4, 4 plus 3 is 7. I'm going to use that pattern instead of continuing to plug in. I could plug in. I just thought the pattern would be easier. So f of 4 would be 3 times 4 is 12, minus 2 is 10. f of 5 would be 3 times 5 is 15, minus 2 is 13. f of 6 would be 3 times 6 is 18, minus 2 is 16. So that table is our first 6 terms, and that's an explicit rule. It tells me, here's how you find the 6th term. Plug in 6, get your answer. Now with example 2, we're going to use a recursive rule. It says find the first 6 terms of a sequence defined by the recursive rule. And again, we're going to go ahead and draw a table. And we want the first 6. So my n is going to go from 1 to 6. Notice this time, they just told me what f of 1 was. It's 4. Now, this recursive rule, f of n equals f of n minus 1. This right here means the one that came before, plus 10. So notice the n minus 1 is on the inside of my parentheses there. So I'm going to use the formula, and then I'm going to actually just kind of use the pattern. So I need to find f of 2. So f of 2 is going to be f of 2 minus 1 plus 10, which means f of 1 plus 10. And we just said f of 1 was 4. So I'm going to replace it with 4, and I'm going to get 14. So to do f of 3, it would be f of 2 plus 10, so 24. To do f of 4, it would be f of 3 plus 10, so 34. To do f of 5, it would be f of 4 plus 10. And to do f of 6, it would be f of 5 plus 10. So the recursive rule is actually a little bit easier to use because it just tells you what to do to the term before. So again, our notation here, f of n, to find your term that you're looking for, f of n minus 1. That means the term that came before it. So to find f of 6, I need to know f of 5. We have a little bit more notation to talk about, and then we'll do some practice with these. We've been using our function notation here for our first two examples, but I want to show you this subscript notation. So for our first term, we called it f of 1. In sequence notation, we say a sub 1. So this just means the first term. I don't know why we use a, but we do. So f of 2 would be our second term. And my notation using the sequence notation or the subscript notation would be a sub 2. So our third term using function notation would be f of 3. Our third term using subscript notation would be a sub 3. And this just means we're going to skip a lot of terms. And we're going to go to our, let's actually go down to our last one, our nth term first. So that would be f of n or a sub n. For our n minus 1 term, we'll just say that. Function notation, f of n minus 1. Subscript notation, a sub n minus 1. So again, these are subscripts. The 1 is small and down. 2 is small and down. 3 is small and down. The whole n minus 1 is small and down, and the n here is small and down. Subscript. Okay. And we'll talk more about these as we define our arithmetic and geometric sequences.